Hi, everyone. Thank you so much for being here. I'd like to welcome you all to the Sustainability Laboratories Conversation Series. My name is Liz Sulkin, and tonight it is my very special privilege to introduce you to Dr. Peter Gleick. Dr. Gleick, a leading scientist on global water and climate issues, co-founded the Pacific Institute in Oakland, addressing environmental connections and global sustainability. His influential work has broadened the perception of water, emphasizing sustainability, human rights, and integrated thinking. Dr. Gleick introduced the concepts of the soft path for water and peak water, advocating for a local water movement. Dr. Gleick is a prolific author and editor and has contributed significantly to scientific literature with numerous papers and books, including the World's Water series, Bottled and Sold, The Story Behind Our Obsession with Bottled Water, and a 21st Century U.S. Water Policy. His latest publication, The Three Ages of Water, presents a revelatory account of how water has intricately shaped human life and history. More than a mere historical narrative, the book offers a positive vision for the future, emphasizing the potential outcomes if proactive measures are taken now. Now I'm going to hand it over to Michael Ben-Eli.
Well, thank you, everyone, for joining. And thank you very much, Peter. It's really wonderful to have you. I think we heard this wonderful introduction. Why don't we start with a more personal kind of way? Why don't you introduce yourself to the audience? Tell us about where you grew up, what made you choose your professional field, what were major events in your development, mentor, inspirations, things of that nature. Take your time and introduce yourself that way.
Okay, very good. Thank you, Michael. Well, as you heard in the introduction, I'm Peter Gleick. I'm the co-founder and senior fellow at the Pacific Institute in Oakland, California. I'm a scientist by training. I work on climate issues and water issues and broadly on sustainability issues. I grew up in New York City at a time, really, I guess, in the 60s and 70s when the environmental movement was becoming a big deal. Rivers were catching fire and oil spills were happening. And there really was a growing awareness when I was in high school and then in college about some of the environmental challenges that we faced. And I've always had an interest in environmental issues. I studied engineering in college, although I decided I didn't really want to become an engineer. It was the time of the energy crisis, the environmental crisis. And so I took a path looking at the science of the environment, the role that the environment plays in our lives. I went to graduate school at Berkeley, UC Berkeley, in a group called the Energy and Resources Group, which is an interdisciplinary graduate program where I got my master's and doctorate, and studied a wide range of issues related to climate and water. I then helped start the Pacific Institute, a nonprofit research institute here in Oakland, California, that focuses globally on water issues, founded the Institute in 1987, and I've been working on climate and water issues ever since.
Great, that sounds wonderful. Let's start with a little bit of context. Water, the stuff of life. What makes water such a special substance? What's the unique significance of water and the kind of characteristics that how would you describe water as we enter this conversation today?
Well, of course, I think of water as a unique resource. It's in many ways, except for air, perhaps, the air around us, it's the most important resource to us. It's connected to everything we care about: human health, ecosystem health, our industrial productivity and use. It's connected to the climate. It's connected to the environment. It's connected to the way we grow food. It's really a wonderful resource from all sorts of points of view. In the book, The Three Ages of Water, I talk about really the origins of water, going all the way back to the Big Bang. The Big Bang occurred, and apparently within literally a few minutes or maybe a few years after the Big Bang, the first atoms of hydrogen were created. And oxygen took a little bit longer. The first stars had to form and coalesce and eventually grow old and blow up and creating oxygen. But once we had hydrogen and oxygen, we had water. And the reality is that ubiquitous, everywhere you look around the universe, we see water in other galaxies, throughout our solar system, on other planets, on asteroids, and of course, here on Earth. And without water, there would be no life. It's another reason why it's such a unique resource for us, at least the only form of life that we're aware of. Without water, you and I wouldn't exist. And so for all of those reasons, I just find it to be a wonderful resource, a wonderful a molecule, a wonderful thing to think about.
Is there anything to add about the chemical characteristics or mechanical characteristics of water that makes it unique in some ways?
Well, so one of the unique things about water, of course, is it's best understood as having three states: gaseous, liquid, and solid, ice, of course. One of the reasons why we're here, why Earth has life, is because all three of those forms of water exist here. We have water in its atmospheric gaseous form. We have liquid water, of course. We have ice. We see water on Mars. We see water on the moon in ice and deep craters. We actually see water in deep craters of Mercury. But the unique characteristics really of Earth, combined with the presence of water, is I think what has made life here possible.
So what is thinking today about the not the cosmic origins of life of water, but the origin of water on our planet? How did it get here? Did it form here, or was it?
Yeah, so that's still actually somewhat unresolved. There are a number of theories. One is that the water came with the gases that created the Earth, the primordial gases from which the Earth coalesced, and that the water was already there. I think that's probably the strongest theory at the moment, although there's also a theory that the Earth formed 4 billion years ago, and it was a dry Earth, and the water was then brought to Earth from wet asteroids and wet comets from the outer parts of the solar system that are a little bit colder, that brought the masses of water here to Earth, again, around 4.5 billion years ago. But we do know that water has been here for basically from the beginning. We do see a lot of water in the outer solar systems, in the outer part of the solar system. For example, the planets Uranus and Neptune, they're relatively small, but they actually have more water on them in ice than is here on Earth. So again, we see water throughout the solar system, but the Earth is quite unique.
I think another fascinating aspect to it is the whole issue of the water cycle, which is obviously a very complex something of flows and purification and storage and so on. Could you describe a little bit at length, actually, the water cycle on the planet, the structure and characteristics?
Sure. So, of course, I'm sure all the listeners remember the hydrologic cycle from their second grade science classes. But again, we have water on this planet in the atmosphere. We have water in liquid forms in the ocean and lakes and rivers. We have water and ice in the ice caps of Antarctica and the ice caps of Greenland and glaciers in the mountainous areas. And the hydrologic cycle is actually very simple. We have evaporation. The sun brings energy to the Earth. We have evaporation of water off the surface of the Earth into the atmosphere. It then condenses, it forms clouds, and then rains out. It precipitates back down to the Earth or to the oceans, and then it runs off back to the oceans. And that's the hydrologic cycle: evaporation, formation of clouds, precipitation, runoff, back to evaporation. That's also the climate cycle. That's what drives a lot of the weather. It drives a lot of the atmospheric dynamics that we see around the planet. And it's how we get our water resources, really.
Perhaps something that will be relevant to some of the question that we'll explore a little later, but the whole process of water kind of purifying itself as it goes through that cycle and how it goes into the aquifer. Could you talk about this a little bit?
Yeah, so nature is a wonderful water purifier. When we see evaporation, the 97% of the water on the planet is salt water. It's the oceans, the water in the oceans. When the water evaporates off the oceans and goes into the atmosphere, it leaves behind the salts. That's in fact why the oceans are salty, because the minerals are left behind. And the pure water goes into the atmosphere, and rainfall is remarkably pure, and our rivers, absent human contamination, are relatively pure. And so the hydrologic cycle is also a purification cycle for our water resources. Most of the water on the planet, before humans played a role in mucking it up, has always been quite pure.
Now, in your work, you've been emphasizing the historical interplay between human society and water. And in your water, you suggested to differentiate between three ages of water. Could you describe the key characteristics of the first two ages?
Sure. So the book is called The Three Ages of Water. The subtitle is Prehistoric Past, Imperiled Present, and a Hope for the Future. And in my book, the first age of water encompasses the time really from the Big Bang through the formation of water, the creation of water, the formation of our solar system and Earth, through the first civilizations, the first empires, the evolution of Homo sapiens, and the creation of the first empires along the great rivers of the ancient Middle East and the Indus rivers and the Indus River in southern Asia and the great rivers of China. And the idea is that in this first age of water, we Homo sapiens started to learn how to manipulate the hydrologic cycle. We built the first empires. We invented agriculture and religion and writing and irrigation. We built the first dams. The very first water laws were literally carved in stone and uncovered by archaeologists from the ancient Middle East. The first water wars were, again, between the Tigris and the Euphrates rivers, fighting over irrigation canals. And that's really the first age of water. The second age of water I describe is really our age. It's when we started to outgrow, our population started to outgrow those early empires. And we needed to learn how to have a different relationship with water. And the second age of water is also the Islamic Revolution and the Islamic Golden Age and the Renaissance, when science and technology and culture were expanding. And we learned really how to integrate science and technology with our needs to manage the hydrologic cycle. And we grew up in the second age of water. And the end of the second age of water, I believe, is now. We're coming to the end in a series of water-related crises that we can explore, I think, as the conversation continues. That leads to the need for what I describe as the third age of water, a hopeful, sustainable future.
Let's take a step back. I mean, one thing that is so fascinating about the first age is the prevalence of all those mythologies of floods as a beginning of something. And I wonder if you could go into this a little bit. I always found those stories and their appearance in so many different cultures really intriguing.
Yes, of course. So most of us remember the story of Noah, where a vengeful God punishes humanity for its transgressions and floods the earth after warning Noah and permitting him to build a boat to help him and the animals survive. But in fact, the story of Noah is preceded by many other ancient legends older than the legend of Noah. The Epic of Gilgamesh, the story of Atrahasis, ancient Sumerian stories that precede the story of Noah by thousands and thousands of years, but are very similar, where the gods get angry at humanity for transgressions and punish humanity with great floods, and then permit a flood hero, a Noah or an Atrahasis or a Gilgamesh, to re-establish humanity on Earth. And these stories were uncovered by the archaeologists again in the last century, in the 1800s. We now also understand that perhaps some of these ancient flood stories have their roots in actual floods, actual physical floods that occurred thousands and thousands of years ago along the great rivers of the Middle East, and then were passed down in oral histories in these stories as warnings to humanity about the vengeful ability of nature to impose floods on humanity.
I wonder how much this is relevant to our time and whether we are getting similar messages now.
Yes.
Anyway, the second age of water that is related to the big industrial revolution and all the development of technology and the development of everything that we know as progress has obviously also been associated with tremendous amount of abuse of water. And I think let's spend some time here about examining the different aspects of that abuse that is so important to understand and to act about.
Well, so first of all, the second age of water, again, came about because humanity started to outgrow water resources. We had to learn how to manage water differently. And it was a time when we were able to apply the advances in science and technology and institutions to manage water in a different way. We learned what oxygen and hydrogen were. We learned about chemistry. We learned about the physical properties of water. We learned what water-related diseases were, the diseases that had ravished populations in the first stage of water, but we didn't understand what they were: cholera, dysentery, typhoid, guinea worm, the parasitic diseases that came along with bad water quality. We learned what contaminated water was, and we developed the technology to treat contaminated water. We built the incredible water infrastructure to clean up dirty water, to move water from where we got it to where we wanted it. We learned how to build big dams, not out of stone and rock, as the ancients did, but out of concrete and steel to store water in wet periods to use during droughts or to generate hydroelectricity. Those are the advances of the second age of water. And we've all benefited from those advances, or most of us have benefited from those advances. But now we're also faced with a series of what I describe in the book as unintended consequences of the second age of water. The failure to provide safe water and sanitation to everyone on the planet, what I call water poverty, water-related diseases that we know how to cure but have failed to cure and to prevent in many parts of the world, growing conflicts and violence associated with water resources, the devastating impacts of our use of water on natural ecosystems, and of course, climate change. All of these are challenges that we now face, what I call water crises in different forms, that are coming about at the second age of water and are really demanding that we think about managing and dealing with water in a different way.
Let's explore this a little bit more. Maybe we can dramatize a little bit the abuse, what we are doing to water that is really making that crisis that you're talking about, both in terms of using and depleting storages, but also just polluting water resources everywhere. So maybe you can give us more detailed picture of what we are actually doing there that has to be dramatically changed.
So, of course, there's so many examples of the water crises. We get it in the news all the time. But again, when I was growing up, I think I mentioned the Cuyahoga River caught fire in 1969. It was one of the seminal events in American environmentalism. Cuyahoga River caught fire. The pollutants that we had dumped into those rivers, not just the Cuyahoga, but every major river, was killing all of those rivers. And that led, in fact, to some of the environmental renaissance that started in the 60s and 70s. The Clean Water Act and the Safe Drinking Water Act, two of the major laws that we passed in the United States, were a result of the pollution of the Lake Erie and the Cuyahoga River and the other rivers around. Of course, we know that people are still lacking access to safe drinking water. 2 billion people worldwide, it's estimated by the UN, lack access to safe drinking water and sanitation, not because we don't have the technology to provide it, but because we have failed to do so, because our institutions have failed. We're seeing increasing violence associated with water, where water systems are attacked during conflicts that, in the Ukraine, we're seeing attacks on urban water systems and attacks on dams. We see that consistently in the Middle East in recent years. There are probably 2 million cases a year of water-related diseases, mostly of children under the age of 5, that are all preventable. These are all characteristics of the failure, really, to deal with water in a sustainable fashion.
So two questions there. The first, you mentioned damming. Obviously, the question of dams have become a big issue in recent years, and there have been some push to reverse and actually destroy dams.
Yeah.
What's going on there?
So that's actually a good example of both some of the challenges and some of the growing awareness of the challenges. So we built around the world tens of thousands of enormous dams for flood control and drought protection and to generate clean hydroelectricity for recreation, for all sorts of purposes. And those dams brought enormous benefits to us, but they also had imposed costs to us. They destroyed rivers, they killed fisheries. And in recent years, the growing awareness of the environmental consequences of some of the most damaging or dangerous dams that we've built has led to some efforts to remove dams. In the United States today, we've probably removed 1,000 dams, mostly small, mostly uneconomic, mostly damaging, but increasingly large dams. A big dam on the Elwha River in the Pacific Northwest was removed a number of years ago. This year, 2023, the largest dam removal project in history is getting underway on the Klamath River. 4 dams are being removed on the Klamath River between California and Oregon. These are particularly dangerous or ecologically damaging dams that we have finally decided ought to be removed to help restore some of the aquatic ecosystems that we damaged during the second age of water.
So the damaging and the abuse is not only on the water itself, but also via water on the whole ecosystem and the whole issue of biodiversity. So tell us about that.
So, of course, the biggest environmental challenge associated with water resources is really associated with the water that we humans take out of the systems, the water we take out of our rivers, or the water we overpump from our groundwater aquifers that dries up streams. The most threatened ecological systems on the planet, the most threatened species on the planet, are aquatic ecosystems and aquatic species, fisheries, amphibians, migratory birds that are dependent on waterways. Those are the most threatened, and they're threatened because we take too much water out of those systems. We take the entire flow of the Colorado River, for example, shared by 7 states in the West and Mexico. The Yellow River in China no longer reaches the sea during parts of the year. We're overdrafting our groundwater aquifers. And so the impacts of human use of water on natural ecosystems is one of the big crises that we face, and one of the drivers behind rethinking our relationship with water. In a more sustainable third age of water, we're going to have to acknowledge the value of our natural ecosystems and restore water to them, like taking down dams in some places, like guaranteeing minimum river flows in some places. And that's also beginning to happen. That's some of the good news here.
I think perhaps when you look at a polluted river, you know it right away. But something that is invisible is all the aquifer and the water storage, so to speak. And I think it's very important to understand how much water, where are we there? How are we overusing that storage, so to speak? And what's the balance there?
Yeah, so when most people think about fresh water, of course, we think about rainfall, we think about our lakes, we think about our rivers. But another enormous source of fresh water for human use is groundwater, underground aquifers, where water has accumulated over years or thousands of years, or even longer, because of rainfall seeping into the soils and building up groundwater levels. And groundwater is an incredibly important source of water for humanity. As much as 1/3 of total global food production today comes from groundwater use, groundwater pumping. And unfortunately, we overdraft many of our groundwater aquifers. By that, I mean simply we take more water out faster than nature can recharge it. And so groundwater levels in many parts of the world are dropping, which threatens global food production. We see that in the Great Plains of the United States. We see it in the Central Valley of California, in northern India, in northern China, and in parts of India and Pakistan, where groundwater levels are dropping, threatening food production. And it's almost an invisible problem because we don't, as you point out, we don't see that resource very much. We don't see it physically, and yet we know it's a very serious problem.
Could you give us some sense of the extent, like what percentages are no longer there, so to speak?
Well, of course, it very much depends on the aquifer. They're all very much different. But in parts of the Great Plains and underlying northern Texas and Oklahoma and parts of Nebraska and parts of Kansas, what we call the Great Plains aquifer or the Ogallala aquifer, water levels have dropped hundreds of feet. And in some parts of those aquifers, farmers can no longer afford to pump the water. It's simply too expensive now to run the electricity or the diesel to pump that groundwater to the surface any longer. And in parts of China, again, in parts of California, and parts of India, groundwater levels have dropped hundreds and hundreds of feet, and it's now becoming uneconomic to tap into the remaining resources. It's like oil. When you overdraft, when you pump all that out, eventually it becomes too expensive to get anything left.
Which brings to mind another issue that I always felt very strongly about myself, but the whole question of privatization of water and the use of water as a commodity,
right?
So and giving it a value in dollars and all of those kind of things. Maybe you can educate us about what's going on there as well.
Yeah, so this, of course, gets to one of the economic challenges associated with water. We don't treat water properly from an economic point of view. We underprice it, or even though at the same time it's a human right. The UN declared a human right to water in 2010. So we've not done a good job of balancing the human right to water with the economic value of water. Here in the United States, most of our water systems, our infrastructure, is public. Most of our water utilities are public agencies, public utilities. But in some places, there has been a drive to try and privatize water systems because of a belief that maybe a private company could run a water system better than a public agency. That, in fact, historically turns out not to be true. A well-run public agency is just as effective and can be just as efficient as a well-run private water agency. And there are other challenges associated with privatization of water. Profits don't, in a public water agency, there are no profits. The water investment is reinvested in the water system, but in a private agency, sometimes those profits are taken out and leave the area. This is a challenge right now in England, where the water systems were privatized in the late 1980s by Margaret Thatcher, and most of the investments have now not been reinvested. Most of the revenues have not been reinvested in the water systems there. And one other form of privatization, of course, is bottled water. Bottled water is basically private companies taking a public resource and turning it into a private commodity and selling it back to us for thousands of times the cost of what comes out of our taps.
Do you have I don't know how to express it, but it looks to me like there is a really profound I don't know, ethical, spiritual issue there. The whole notion that you can own water. Soon enough, we'll sell the air that we breathe, that somebody can make profit of it. Do you have any feeling about that aspect of that question?
I do. So
it seems to me like an absurd.
And that's an enormous part of the debate about privatization. As I said, the UN declared a human right to water. It's the responsibility of governments and communities and individuals to provide access to safe water and affordable sanitation to everyone on the planet. That doesn't necessarily mean that the water has to be provided for free. We have to invest in the infrastructure to clean up water, to bring it, to deliver it to people, to collect wastewater and treat it again. But one way to think about it is that maybe the water is free, but the water services, of course, have to be paid for. And the human right to water also means that if, for reasons of poverty, people can't afford to pay for water, you cannot deprive them of water. It can't be a private good in the sense that you can deprive people of access to basic human needs for water resources. And I think that's a universally held belief. It ought to be.
Before we take the next step, maybe we can talk a little bit about water and conflict.
So one of the things we do at the Pacific Institute, my research institute, is we maintain something called the water conflict chronology. And if you're interested in history or interested in environmental security issues, I urge you to look it up. It's just Google water conflict chronology or go to the Pacific Institute's website, which is pacinst.org. It's an open source database. It looks at water conflicts going back thousands of years to that very first water war in ancient Mesopotamia in 2400 BC. And we look at water as a trigger of conflict, where there's competition over access or control of water. Water is a weapon used during conflicts, not water wars, but conflicts that may start for other reasons, but where water or water systems are used as weapons. And the third category is where water or water systems are targets or casualties of conflict. We've seen this in the Ukraine in recent years, where civilian water systems have been bombed directly. The dams have been attacked. The largest dam, one of the largest dams in Europe, the Kakhovka Dam and Reservoir, was destroyed last year in June as part of that war. So there are many, many examples where water and conflict are related. And the bad news is, in the last few years, we've seen a dramatic increase in the number of water conflict events, where there's growing competition for water. There are riots over access to water. There are attacks on water systems during conflicts around the world. All of those categories that I've described have seen an increase in recent years.
Now, all of those kind of adverse impacts and adverse conditions and abuse and stuff that we discussed, you still have a very positive view that we are living that stage of behind, becoming aware and conscious of what we're doing, and therefore we are entering the third stage of water, which will have to do with the restoration of water to its pristine conditions, and kind of conserving planetary water, and so on. So what are the imperatives, if perhaps the way to look at it, what are the imperatives of the third age that we are entering? What will make it succeed?
Well, so the third age of water that I describe is a positive, sustainable future. I truly believe that we can move to a positive, sustainable future for water. The imperative that's driving it, of course, are these crises now at the end of the second age of water, the problems that we know we have to solve. And the reason I believe that we can move to a sustainable third age of water is because I see all around me, in the experience and the work that I've done, the work I've done with colleagues around the world, I see success stories. I see examples where each of the challenges that we face are being solved, not necessarily as quickly or at the scale that we need to solve them. But I truly believe that we can solve them. I know that we can provide safe water and sanitation to everyone on the planet without having to invent some magical new technology at costs far less than the economic costs of failing to provide that safe water and sanitation. I know that we can solve environmental problems associated with water and reduce the risks of conflicts over water resources. So I describe in my book the idea of a sustainable third age of water and the strategies for moving forward to this sustainable future.
Okay, let's go through some of those, the description. What are those things that needs to be done? Actually, if you can say a little bit more about examples where we have been successful in doing things right, that will be great to hear as well.
Well, we've talked about some of them already, but by far the most important for me is addressing what I call in the book water poverty, this failure to provide safe water and sanitation to everyone. The Sustainable Development Goals of the United Nations, there are 17 of them. They address a whole range of issues, but one of them, of course, is water. Sustainable Development Goal number 6 sets a target to provide safe water and sanitation to everyone by the year 2030. And I don't think we'll meet that target. We're behind schedule already, but I know that we can. So sometime we will meet that target. We will be able to provide safe water and sanitation to everyone, and that will cut conflicts over water, over access to water. It'll reduce water-related diseases. It'll have a whole set of positive impacts. We've talked a little bit about some of the need to restore ecological flows of water, to protect rivers, to take down the most damaging dams. And we've already talked about some of the examples of moving toward some of those more ecological restoration activities. And I know that we can do more of that. And we're seeing a growing awareness of the importance of ecosystems, not just for themselves, but for our own health and well-being. I know that we can reduce conflicts over water with diplomatic efforts, with international law, with providing safe water to everyone, that will reduce tensions over who controls water resources, with better agreements on rivers that are shared across borders. These are some of the strategies that I already see moving toward in the third age.
There is a balancing act here. You're talking about providing fresh water for everyone on the planet, like the UN goal of what's the other side of that coin? What are the conditions? We don't want to use more of the aquifer in order to reach that goal, right? So there is a balancing act there that relates to water itself, not so much to the needs of humanity. So what would you say about that?
Well, so the good news is that the amount of water required to provide everyone on the planet with their basic needs is a very, very, very small amount of water compared to how much water we use for a wide range of other things. 80% of the water that humanity uses goes to agriculture to grow the food that we need. And so part of the third age of water is also what I call an efficiency revolution. How can we do the things that we want with less water than we're currently spending to do them? How can we grow more food with less water, with smarter irrigation technologies? And we're already beginning to do that. We're growing more food with better irrigation systems, with remote sensing, so that farmers only water when the field needs it, rather than when they think they need it. We're changing crop types that's permitting us to grow more food with less water. Our industries are producing more goods and services with less water. We're in the middle, again, of this transition in an efficiency revolution that will permit us to do what we want and meet our needs with much less water, much less impact on ecosystems, and of course, easily provide the water that's required for basic human needs.
It looks to me that in order to be successful in moving in the direction that you advocate, we need to recognize in a more profound way the value of water. And I think that there have been a few examples of moving in that direction, perhaps with talking about water rights and water law. Where are things there?
Yes, of course, one of the challenges is that we have never really properly valued water in any sense. You know, one of the reasons we have ecological problems is because we've assumed in the 20th century and the 19th century that the value of the environment was zero, and that we could just take resources from it, whatever resource we want, and not worry about or suffer the consequences of those ecological problems. And there's a whole new field today called ecological economics that is acknowledging the need to value ecosystems in a different way, to figure out how to integrate ecological values into our economic system. And as we improve the concepts of ecological economics, we will also improve our ability to use water more carefully. So changes in economics are an important part of this. But you know what? Changes in our institutions are also really important. Water rights, you know, we've given out water rights in the Western United States, for example, again, without understanding the importance of ecosystems, or without recognizing the indigenous rights of the people who were here long before Western culture appeared. We gave out water rights to farmers and to miners. And now there has to be a discussion about how to rethink about water rights in a more equitable fashion.
It seems that from the physical kind of aspects of things, there are a number of things that stand out, like the idea of protecting and restoring water, the whole notion of avoiding waste. We're obviously very wasteful in the way that we treat water resources. And of course, the whole issue of recycle and reuse. And maybe you can talk a little bit about this.
So that's actually another very important characteristic of what I think of as the third age of water. We're, of course, running into problems with finding new sources of water. We're overtapping our rivers, we're overtapping our aquifers. We have this idea that as populations and the economy grow, we have to find more and more water, a fact that, in fact, I believe is no longer true. But one of the important new sources of water that don't require taking more water out of rivers or already overdrafted aquifers is collecting and treating our wastewater, which we already do to some extent, and recycling it and reusing it. We have the technology today to take the worst quality wastewater, the most contaminated water, and produce the most pure water on the planet. Singapore today collects and recycles and reuses 100%, almost 100% of their wastewater. And some of their treated wastewater is so pure, they use it in their semiconductor industry, which requires ultra pure water, much purer than even required for drinking water. Israel today collects and treats and reuses 85 or more percent of its wastewater, mostly for agricultural use. California, we collect and treat and reuse about 18% of our wastewater, but we're talking about doubling or tripling that. And that's a resource. We think of wastewater in the old days as a liability, but today it's an asset. It's something that we need to collect and treat to the right standard and put back to use. And of course, this is what they do on the space station, where it's incredibly expensive to lift water out of our atmosphere and bring it up into space. And so they have systems on the space station that recycle almost 100% of their water, and they reuse it over and over again. And those systems produce very pure water.
Actually, this is something that always fascinated me, that the water in the space missions, water in space, where astronauts have to stay out in stations for a year or longer. And so the technology there can be a great model, at least for the recycling part and not wasting part. And I don't know if you can enlighten us a little bit about that aspect. The whole notion of a spaceship Earth, right? Managing those resources the way we manage it in a spacecraft. What's the story there?
Well, that's exactly right. I mean, the truth is we're in a little spaceship Earth. And, Buckminster Fuller described this many, many years ago. The astronauts who have gone into space and looked back upon the Earth, they have a great perspective on this. And many of them come back with a whole new appreciation for the need to manage our environment in a much more sustainable fashion. And of course, the space station is a little enclosed world. We are able to bring food resources and water resources up to them, but it's incredibly expensive to do that. And so we've built systems to recycle as many of those materials as we can. And of course, when we think about moving out into space, humanity moving to Mars or to building colonies on the moon, we're going to have to depend on water resources that are there. We're not going to bring water from Earth because it's too expensive to do that. It's no accident. About a month or two ago, in a remarkable technological feat, India landed a rover on the moon. And the place they chose to land was very close to where we have seen water ice in southern craters on the moon. Because if we can find water on other planets, we can produce oxygen, we can produce fuel, we can produce energy. Our ability to move out into the solar system is ultimately going to depend on our ability to both find water and to manage it in a sustainable fashion.
Now, in addition to groundbreaking technologies, which are obviously required in some of those areas, some of which you maintain that we already have, implementation of active steps to bring about and secure the third age of water that you would like to see will obviously require a totally unusual collaboration and agreement and integration of actions between local authorities and national authorities and the international machinery and so on. So making good progress in this regard. Are we making good progress in this regard? What is happening with the so-called international push towards different aspects of biodiversity, climate change, and so forth? Are we making any progress there with respect to water now, no other issues?
Well, of course, I do believe we are making progress. I believe we're in this transition to a sustainable future. It's not as fast as I would like. We're not going to reach this positive vision that I have in my book for water in my lifetime, but I do believe we'll reach it. And probably the biggest challenge is the institutional challenge, the management challenge. I've said several times, I don't think we need to invent new technology. I think we can restructure our economies in ways that recognize some of the economic benefits of dealing more appropriately with water. But our institutions are bad in the water area. Our water institutions don't talk to our energy institutions, for example, and energy and water are very tightly connected. Our land use is old and outmoded and doesn't take into account some of the ecological and water-related issues that are facing us. At the federal government level in the United States, we have 20 different agencies that manage water resources. There's no single department of water, but we would manage water much more effectively if we thought about water in an integrated way. And that's true at the international level as well.
Which things I don't see those happening fast enough. That's why I'm pushing for your view about the institutional blocks that are on the way. It's like blood clots that are not allowing the flow to go through.
Yeah. Well, of course, I don't believe they're happening fast enough either, but they are beginning to happen. So the UN, for example, has had many organizations over the years related to water. Food and Agriculture's over here. They have a climate group over here. They have a water agency. They don't have a water department specifically, but they have now created something called UN Water that integrates the World Meteorological Organization, the World Health Organization, the Food and Agricultural Organization to manage water resource issues in a more single institutional fashion. And that's a good sign. There's more and more realization that countries have to agree on how to share water resources that cross borders. I do believe these institutional changes will occur, but like you, I wish they would happen faster.
I hope it will. I think there is another elephant in the room here, and that is climate change, of course. And maybe you can explore a little bit the nexus between climate change and water, because that, of course, is an area that touches on everything else.
I think, like we said in the introduction, I'm a climate scientist in part by training. I've done a lot of work over the years on the impacts of climate change for water resources. And the hydrologic cycle that I described at the beginning, evaporation, formation of clouds, runoff, precipitation, that is the climate cycle as well. And we know the climate science community understands very well that some of the worst impacts of climate change will be on and are already starting to be evident on water resources. Higher temperatures means more demand for water and more evaporation. More water in the atmosphere means more intense storms. We're seeing changes in the frequency and intensity of both floods and droughts. Sea level rise is causing contamination of coastal aquifers and hurting coastal freshwater ecosystems. So climate and water are very closely related, and we're already observing impacts of climate change on water systems, and we have to do what we can to both slow the rate of climate change and now, unfortunately, deal with the unavoidable consequences of those changes we can no longer avoid.
Well, COP is going on, for climate change is going on right as we speak. And I don't see very many dramatic news coming out of it. And so it looks like many of those issues that we talked about earlier of more droughts, more floods, more whatever are inevitable. But I hope that your optimism will reign at the end of the day.
Yes, of course, COP isn't over yet. We don't know what the final conclusions and agreements will look like. But there's no doubt that we're not acting quickly enough on climate. No matter what comes out of COP, we're already way behind the curve, decades behind where we ought to be on slowing the rate of emissions of greenhouse gases. And so we're now faced with unavoidable impacts of climate change that we could have avoided if we had acted decades ago. But that doesn't mean we shouldn't be acting now. We should still be acting as quickly and as fast as we can to both slow the rate of future climate changes, but also now to adapt to those impacts that we can no longer avoid.
I think maybe the last question that I will have before we turn it to the audience, and perhaps it's a little bit unfair, this question, but basically we're addressing here issues of water from an anthropocentric point of view, which is natural, of course. But if you were water, what would you have to say to humankind?
Well, what I would say is what I say to human audiences anyway, as a human, which is we need to understand the incredible value of water, the importance of water for everything that we care about. And we need to understand where our own benefits and where our own water comes from, And the more we understand, the more likely we are to take care of our water resources, the more likely we are to act to prevent the bad consequences of the second age of water and to move more quickly to the third age of water. And the truth is, people really care about water. You know, the good news is water, of all of the things we fight about, is a pretty nonpartisan issue. You look at public opinion polls, Democrat, Republican, liberal, left, right, liberal, conservative, people care about water. That's one of the reasons why I have hope that we can move toward these more positive futures, because when people understand the nature of water, the challenges that we face, and the possibility of doing things better, then things happen faster.
Thank you very much, Peter, and thank you for your very important work. It's really wonderful.
My pleasure.
I think I really applaud your optimism. We all have to take that view, I think, of the future in order to sustain our energies, to work in that direction where everything else seems to be going in exactly the opposite way. Thank you all for joining. Thank you, Liz. Thank you, Nicole. Thank you, Peter. And good night.